folks, in this video we're going to go over how to perform the product and quotient rule whenever you have logs, namely natural logs and exponentials in your function. So this will be a quicker video. Please, if you're not familiar with the product and quotient rules, go back and watch the video before this. That's a more in-depth explanation of the product rule and quotient rule. But here I'm just going to show you how to do it with logs and exponentials. All right, so for example, suppose f of x is x cubed times e to the 8x. Keyword there is times, which means we have to do a product rule. And so just a quick little refresher, a product rule is if I have one function a times another function b, all right, we know that the product rule says f prime of x is, I take the derivative of the first function times the second function left alone plus, and I flip it, derivative of the second function times the first function left alone. All right, so here we go. So our derivative will be, we have to take the derivative of x cubed, because x cubed is our a in this. E to the 8x is our b. So the derivative of x cubed is the 3x squared, and then that multiplies e to the 8x. Okay, so for, if you want to label, that's a prime times b plus, okay, plus, now we take the derivative of e to the 8x. So if you don't remember that, go back to our derivatives on exponentials video. But the derivative of e to the 8x is, remember, the power on e doesn't change. The power stays the same, but e to the 8x gets multiplied by the derivative of that exponent. The derivative of e to the 8x is an 8. So that's where that 8 comes from. It's the derivative of that power, of that exponent. So all of this is, let's see, this is b prime, and then it's going to multiply a, in our case, which is x cubed. And that's it, folks. That's how you take the product rule with exponentials. Okay, where that's a. All right, I guess I'll take it one step further. Let's say we wanted to simplify this by factoring. All right, what I mean by that is, let me circle my plus. What if I wanted to pull out the greatest common factor? Well, what do I have in common? I like to go in order. When I look at 3 and I look at 8, they have nothing in common. I look at x squared and I look at x cubed. I say, okay, I can pull out an x squared. And certainly I could pull out an e to the 8x because that's prevalent on both sides of my plus sign. So x squared e to the 8x is my greatest common factor. What remains? What's left over? Okay, so go back to the left side of the plus here. I'm looking at 3x squared. I take 3x squared and I divide it by the x squared that I factored out. That leaves me with a factor of 3. When I have that e to the 8x, I took out all of that e to the 8x. I divided all of that out. That leaves me with a factor of 1. Plus, now we jump to the other side of the plus. Okay, we said, look, we didn't touch any of that 8. We didn't factor out any of that 8. So since we didn't touch it, it remains inside here. E to the 8x, let's see, we took out all of that e to the 8x, so that becomes a factor of 1. And from that x cubed, we only factored out an x squared, so that means that we have an x to the first left over. And all that's left is for us to simplify the brackets. And I'm going to convert it back to parentheses. 3 times 1 is 3. 8 times 1 times x is a plus 8x. And that is our fully factored answer. So if you're doing your homework, if you don't see the answer in your work, what may have happened is that the program may have simplified their answer via factoring. So yes, know how to simplify your answer by pulling out the greatest common factor. All right, here we go. F of x equals 4e to the x over the natural log of x. They want us to find f prime of 2. Okay, so what that means is we need to find our derivative via the quotient rule, and then we need to then plug in 2 for x. All right. So let's see here. So the quotient rule, maybe we should write that down. The quotient rule is what I like to refer to as a yodel. It is low d high minus high d low over low squared. I call it a yodel because if you say that really fast, it sounds like a yodel. All right, so here we go. F prime of x equals low. What's our low function? Our low function is the natural log of x times the derivative of the high function. We have a 4 times e to the x. The derivative of 4e to the x is, well, a 4e to the x. Well, the derivative of e to the x is 1e to the x times 4 means it's 4e to the x. Minus, here we go, high d low. High is a 4e to the x times d low. So the derivative of the natural log of x is a 1 over x. It's the derivative of that argument, that 1x over x. So derivative of 1x is 1, put it over x. All over low squared, which is a natural log of x quantity squared. All right. Not really going to clean that up. There's not much to clean up there. So what now we could do is, if we want to find f prime of 2, that means we have to calculate the natural log of 2 times 4e squared minus 4e squared times a 1 over 2. I'm just simply plugging in 2 for x. We divide that by the natural log of 2 squared. Okay, what's next is I'm going to get a numerical answer for this, or I should say a numerical approximation. I'm going to throw all of this into my calculator. Okay, so here we go. I'm going to do open parentheses for my numerator. It was the natural log of 2 times 4e squared, c power of 2, minus, minus 4e squared times 1/2. What I'm going to do is put the 1/2 in parentheses. 1 divided by 2. Okay. And then I'm going to close parentheses. So that's my entire numerator. And then it now needs to be divided by the natural, open parentheses, the natural log of 2. Close it up. And I want to square that quantity. Okay. And then close parentheses for my denominator. There we go. Assuming everything looks good. There we go, folks. 11.88 is what I got there. 11.88. Okay. All right. So that's what happens when you have to plug in a particular x value. Let's see. I think there's one more. All right. Here we go. This is the last one. All right. F of x is 10x to the 5th over e to the x. Find f prime of x. Okay. So once again, we are doing the quotient rule. The quotient rule. So f prime of x is low d high. So we take our low of e to the x times the derivative of the high. 5 times 10 is 50. X to the 4th power. Excuse me. Minus high d low. So that's going to be 10x to the 5th times the derivative of the denominator. So the derivative of e to the 1x is a 1 e to the 1x. Okay, and then we put that over low squared, which is going to be e to the x quantity squared. All right. Okay, next what I'm going to do is I want to factor my numerator and see if I can clean up this overall answer. So the derivative is done. Now we're just factoring and simplifying the answer. So let's see here. Certainly there's an e to the, actually let's do this. Let's circle our minus. There's an e to the x that's prevalent on both sides of our minus, so we can certainly factor that out. And then I have a 50x to the 4th on the left and a 10x to the 5th on the right. So that means we can pull out a, let's see, a 10x to the 4th. Okay, how did I figure that out? Between 50 and 10, what's in common? 10. Between x to the 4th and x to the 5th, what can we pull out? An x to the 4th. Okay? All right. What's left over once we divide out a 10x to the 4th e to the x, okay? Look at strictly to the left of the minus right now. Focus on just to the left of the minus. Okay? The e to the x divided by the e to the x is going to leave us with the factor of 1. I'll go ahead and write it. 1. 50x to the 4th divided by 10x to the 4th, that leaves you with a 5. Right? 50 divided by 10 is 5. X to the 4th divided by x to the 4th is 1. Minus, okay, now let's focus on this side. Let's take a 10x to the 5th. We divide it by 10x to the 4th. That leaves you with a 1x to the 1st power. And then the e to the x was already divided by e to the x, and that leaves you with a factor of 1. Okay, and this is all over. Okay, so e to the x squared is a e to the 2 times x power. Where in the world did I get that from? So a little bit of algebra review. If I have x to the a times x to the b power, That's when you add the powers, a plus b, x to the a plus b. If I have x to the a divided by x to the b, that's when you subtract the powers. But when I have x to the a raised to the b power, that's when you multiply the powers. And that's what we have here. We have e to the x raised to the second power, so I'm multiplying those powers because I'm taking a power, raise it to a power. That's where I get 2x power from. All right, so let's see here. Next step is let's clean up the parentheses. So 10x to the fourth e to the x times, sorry for my handwriting, times 1 times 5 is 5 minus a 1x over e to the 2x. And then the last thing I'm going to do here is I notice that, hey, I have an e to the x as a factor in the numerator, an e to the 2x as a factor in the denominator, and some of that's going to cancel each other. Okay, because they're factors, they're multiplying. So e to the x cancels, and this e to the 2x now becomes an e to the 1x power. So my final answer is 10x to the fourth times 5 minus x over e to the x. Or you may even see it written like this. I could take that 10 and pull it all the way out front. This is an equivalent answer as well. You may see the answer written like that, but they're the same thing because you're saying that the 10 is understood to be over 1. But anyways, yeah, so the moral of the story is if you're doing your homework and you don't see your answer, try simplifying it and see if your answer matches up with the homework. All right, so that's a quick little video on how we do product and quotient rules with exponentials and logs. Hope to see you in the next one.